Hey class, welcome to another science lesson. This is Gravity Part 3, Weightlessness. If you haven't done parts 1 and 2, go ahead and start with those first, because some of the things I'm talking about might not make a lot of sense if you haven't yet. So, last time we looked at um, air resistance and the feather and the hammer. You hopefully saw in the video on the moon where the astronaut dropped the feather and the hammer at the same time and they hit the ground at the same time because there's no air on the moon, so there's no air resistance. So gravity is pulling on all objects the same. So it's a little bit different in how you experience on Earth. So you might be going, oh, okay, I get it. Gravity pulls things downwards, pulls things towards the center of the object with the most mass. Yeah. The apple from the tree falls straight down no matter where you are. If you are in the North Pole, the South Pole, if you are in Washington State, if you are in South Africa, Australia, Japan, China, wherever you are, doesn't matter. It's going to fall straight down. You got it. But you might be going, well, okay, then how do things like this happen? If gravity's always pulling on you, then how on earth do we experience weightlessness? We see it in videos, right? These are videos of the International Space Station where astronauts go, and it's in Earth orbit up above us, not as far as the moon, actually pretty close to Earth. Uh, Other video, it looks like it's showing a dog in weightlessness, but no, I don't think they've brought a dog to the space station. I think it's just made up, but it's kind of funny, so I put it in there. So how on earth does this get to happen? Looks really fun, right? Looks really awesome. So what is happening here? You even probably have experienced at least a brief, like second of the feeling of weightlessness, especially if you've been on a trampoline before, when you're jumping and you have a very high jump, and for just like a brief moment of time, you can kind of almost feel the sensation of weightlessness, that kind of stomach, that feeling in your stomach. You might get a similar feeling if you are in a car and the car suddenly goes down a hill, especially like a steep hill or a hill you're not expecting, and you get that ooh feeling in your stomach. Or you've been on a roller coaster, and when they're going down at such a high speed, you have that feeling of weightlessness when you're going, especially when you're careening down on a roller coaster. Those are all examples of when we can experience weightlessness. Usually, unless you're in space, it's for a very, very limited amount of time. Now, that doesn't mean that gravity isn't there. Now, keep in mind, remember, more mass means more gravity. The pull of gravity is a stronger force the more mass you have. So, for example, on Earth, our home planet, let's say you're a human being that weighs 200 pounds, or that could also be said as 90 kilograms on Earth, and then that same person goes to the moon, all of a sudden they are 33.2 pounds or 15 kilograms. That's a big difference between the moon's gravity and the Earth's gravity. So for those astronauts, usually they're kind of average sized males who went there, all of a sudden they feel a lot lighter. Does that mean they lost a ton of that weight? No, their mass stayed the same. They're still the same person that went to the moon, right? They're still the same. Everything's the same inside of them. But on the moon, that pull of gravity is much weaker than it is on Earth because the moon is much smaller. So there's a weaker pull. So today I'll have a website for you guys to go to, which actually has a calculator, and you can put in your weight. If you don't know your weight, well, maybe ask your parents, or maybe you have a scale somewhere that you can use, or just guess. Um, and you can put your weight and see what you would weigh on different planets. So some planets are you would be very lightweight. You would float around. You'd probably be able to jump further and higher. And some planets you basically would be smushed down to the ground, or you'd be held down to the ground by the pull of the gravity so much you probably couldn't function. And we can't function as human beings on those planets anyways. So it's really kind of cool just to see what your different weight would be. So you'll have a chance to go do that in today's assignment. Um, But just because that pull is less strong doesn't mean it's not around. The gravity on the moon is much weaker than on the Earth because the moon is much smaller. And that's why we get those kind of funny videos of the astronauts kind of doing like a little skip or leap because of how light they felt. Imagine if you're going from feeling like you're 200 pounds to 33 pounds. You could jump, you could move around. And it was very awkward for them to move around, and they had to master this little skipping motion. And there's actually some bloopers I'm going to show you a little bit later on of all the astronauts falling over because of how awkward the gravity on the moon makes you feel. So here's a special point. This will help you win one of the questions. Gravity is everywhere. Even in space, there's always a pull of gravity, but it can be much, much weaker, especially when you're far away from those objects. So when you're an astronaut and you're in a spacecraft between the Earth and the moon, there's still the field of gravity. There's still a pull of gravity, but you don't feel it as much as you do when you're on planet Earth, right? That's our normal setting of gravity, what feels normal to us. And then when you're on the moon, there's less gravity, but more gravity than if you were out in space, right? You're not going to feel much pull anywhere. But even everything is going to be having some sort of slight pull of gravity somewhere. Even the most distant stars have some pull of it. So what we want to take away here is people feel weightless in some situations. We feel weightless. There's no such thing as zero gravity. We like to say zero gravity because it's an easy way to think of that like gravity's effect on us is minimal. Actually, technically it would be called microgravity since there's gravity, but its effect is less. So we feel weightless in some situations, but there is still the pull of gravity between them and other objects. Doesn't mean gravity went away. We can't make it go away, but we can feel weightless sometimes. And one of those you're going to see today is from a plane called the Vomit Comet. It's, again, literally called zero G, even though you don't actually experience zero G. It's a plane, a jetliner that flies in this shape called a parabola. It goes up very, very steep, and then at the peak of that crest there, like right at the top of the hill, is when the people riding it, like you can see in these pictures here, experience a few moments of weightlessness. And then the jet goes down. You feel twice the amount of gravity as it's going down because you're kind of stuck to the floor. And it repeats this process over and over again. This is so astronauts can train. This is also so people can experience it, for fun. And so you'll see this with James May from BBC, and he talks about it. And then you're going to watch one of my favorite music videos of all time from OK Go, Upside Down, Inside Out, that was filmed in one of these special planes. This was actually filmed with them actually weightless. This filmed in zero G, so to speak. So they had to film like a couple seconds at a time. I think they had 15 seconds for each time the plane went up and they felt weightlessness. So I've got these videos for you to watch. I've got the website for you to enter your weight on other planets, and a couple questions in the Google Doc. That's what I have for you guys today. Nice talking to you guys. I'll see you in the next Zoom meeting, and have fun, stay healthy, and keep learning.